Energy is the capacity for doing work. It is the process of transfer from one body to another. There are different types of energy, which includes thermal energy, radiant energy, chemical energy, nuclear energy, electrical energy, motion energy, sound energy, elastic energy, and gravitational energy. In this lesson, we will focus more on your kinetic and potential energy. So your kinetic energy is the energy in motion, meaning this kinetic energy are energy that is produced by moving objects. So the formula for kinetic energy K is equal to 1 half mv squared. So take note that kinetic energy or energy is a capacity for doing work. Therefore, energy has the same unit as work, which is joules in SI unit. So the summation of work in kinetic energy is equal to the integral of ftx from xi to xf. The kinetic energy is a form of energy that an object or particle has by reason of its motion. If work, which transfers energy, is done on the object by applying a net force, the object speeds up. And thereby gains kinetic energy. Kinetic energy is a property of a moving object or particle and depends not only on its motion, Vf, but also on its mass m. The kind of motion may be translation or motion along a path from one place to another, rotation about an axis, vibration, or any combination of motions. Your potential energy is your energy at rest, meaning this energy is based from its position. Potential energy is the energy stored within an object due to the object's position, arrangement, or state. It is often convenient to establish some particular location xi of one member of a system as representing a reference configuration and measure all potential energy differences. So considering this free body diagram, you may see that at this point, at the point y, your potential energy is equal to Ug equals mgy. Mass multiplied by gravity multiplied by y. This formula is called your gravitational potential energy. There is another type of potential energy which is your elastic potential energy, which will be discussed in separate video presentation. So take note that the W net of a potential energy is equal to negative change of potential energy. Work-kinetic energy theorem. In case in which work is done on a system and the only change in system is in its speed, the work done by the net force equals the change in kinetic energy of the system. So W net is equal to delta Ke, meaning we have Ke final or your less Ke initial. This is your W net. This can be proved by the formula, this formula, which in we will know that the summation of W is equal to the integral of x1 to x2 f dx, or the summation of f dx. But according to the Newton's second law of motion, so F is equal to mass multiplied by acceleration. In this case, you all know that your acceleration from our previous lesson is equal to dv over dt. Substituting this to this equation, so we'll have a value of your m, your f is equal to m multiplied by dv over dt. So for further manipulation of this equation, we'll substitute the value of your f. Okay, so we'll have your summation of w is equal to the integral of x sub 1 to x sub 2. Then we will have our m dv over dt multiplied by dx over dt. Dx multiplied by dx. So rearranging this formula, so we have the summation of w is equal to the integral of x sub 1 to x sub 2. So we have f m multiplied by dv multiplied by dx over dt. Take note that x here is the position. And we all know that the derivative of position with respect to time is equal to your velocity. So therefore, we may say that the summation of w is equal to the integral of x sub 1 to x sub 2 multiplied by m, this is v, from this equation, so we have mv dv. So since we will not need this x sub 1 and x sub 2 as limit, our new differential will be dv. So therefore, we will change the limit from vi to vf. So we have the summation of w is equal to the integral of vf and vi multiplied by mv dv. Now, integrating this equation, so we will have a value equal to m v squared over 2. Okay, m v squared all over 2 from the limits of vi to vf, which is equal to our summation of w. Okay, so we will have a value equal to the summation of w is equal to m vi squared vf squared less m vi squared all over 2. So based on this principle, we all know that m vf, the formula for kinetic energy is equal to m vf squared over 2, right? So therefore, we may say that the summation of w is equal to k kinetic energy at final less kinetic energy at initial. So we have the summation of w is equal to delta ke. Okay, that is the derivation of our formula for your work kinetic energy theorem. Summation of w is equal to ke less kef. So let us use the formula in solving these conceptual problems. A 6 kilogram block, initially at rest, is pulled to the right along a horizontal frictionless surface by a constant force of 12 Newton. Find the speed of the block after it has moved 3 meters. Okay, so take note that the block is initially at rest. And then the block is moved is pulled by a 12 Newton force. Find the speed in the block after it must move. So we all know that the summation of W is equal to KA F less KEI. Since the block is moved at rest, so therefore our VI is equal to 0. And you are solving for the value of your VF. Therefore, we'll have a value of 12 newtons as the work. So we have 12 multiplied by 3. Because the formula for work is equal to force multiplied by distance, right? So we have 12 newtons multiplied by 3 meters, which is equal to, since we have no initial velocity, therefore this is 0, and we have our KEF, which is 1 half mVF squared. Okay, so we have our mass, which is equal to 6 kilogram. So therefore m is equal to 6 kilogram. So therefore we may say that 12 multiplied by 3 is equal to 36 joules or 36 newton meter, which is equal to 1 half multiplied by m, which is equal to 6 kilogram multiplied by Vf squared. So therefore we will have a value of your Vf as 36 multiplied by 2 divided by 6. So getting the square root of this one, we will have a value of square root 36 multiplied by 2 divided by 6. So we will have a value of 3.46 meters per second. Next, a 0.6 kilogram particle has a speed of 2 meters per second at point A and kinetic energy of 7.5 joules at point B. What is its kinetic energy at A, its speed at B, the total work done at the particle as it moves from A to B? So a 6 kilogram particle has a speed of 2 meters per second at point A. So at point A, we have the kinetic energy unknown, but we have our mass, which is equal to 6.6 kilogram, our speed, which is equal to 2 meters per second, and then at point B, we have our kinetic energy, which is equal to 7.5 joule. But we have unknown speed. So at A, so we will solve for kinetic energy. Kinetic energy is just equal to 1 half mv squared, which is equal to 1 half multiplied by its mass, which is 6 kilogram, multiplied by its velocity, which is 2 meter per second squared. 2 meter per second squared. So we'll have a value of 1 half multiplied by 0.6 multiplied by 2 squared. So we'll have 1.2 joule. At B, we will solve for its speed. So we will have our kinetic energy, which is equal to 1 half mv squared. So we will have a value of your kinetic energy, which is 7.5 joule, which is equal to 1 half multiplied by 0.6 multiplied by its velocity, which is unknown. So solving for this one, we will have the square root of 7.5 multiplied by 2 divided by 0.6. So we will have a value of 7.5 joule multiplied by 2 multiplied by 2 divided by 0.6. So getting the square root of this one, so we'll have a value of 5 meters per second. Next is the total work done by the force, so letter C. So you all know that your W net is equal to KEF less KEI, which is equal to 7.6 joule less 1.2 joule. So we'll have a value of 6.3 joule. Next problem, a car traveling at a velocity of 10 meters per second and it has a mass of 250 kilograms. Compute its kinetic energy. So therefore these conceptual problems are just direct substitution. So Ke is just equal to 1 half mv squared. So we'll have 1 half multiplied by our mass, which is equal to 250 kilogram, multiplied by 10 meter per second squared. So we'll have a value of 1 half multiplied by 250 multiplied by 10 squared. So we'll have 12,500 joules. That is our kinetic energy. Next, a man is transporting a trolley of mass 6 kg and having a kinetic energy of 40 joule. Compute the velocity with which is he running. So therefore we'll have this trolley at mass of 6 kg and having a kinetic energy of 40 joule. Therefore we'll have a value of Ke is equal to 1 half mv squared, and we have our Ke which is equal to 40 joules, which is equal to 1 half multiplied by mass 6 kg multiplied by v squared. So therefore our v is equal to 3.65 meters per second. Next, a conceptual problem for potential energy. So a box has a mass of 5.8 kg. The box is lifted from the garage floor and placed on a shelf. So if the box gains a 145 joule of potential energy, how high is the shelf? So you all know that potential energy, or your PE, is equal to mgh. So therefore, we have our potential energy as 145, which is equal to mass is 5.8 kilograms multiplied by 9.81 meters per second squared multiplied by its height, which is unknown. So therefore our height is just equal to 2.5 meters, 2.55 meters. Next, a man climbs on the wall that is 3.6 meter high and gains 2,268 joules of potential energy. What is the mass of the man? So, PE is just equal to mgh again. So, we'll have a value of 2,268 joule, which is equal to 3.6 meters multiplied by m, which is your mass, which is unknown, multiplied by 9.81. So, therefore, meters per second squared. So, therefore, we will have a value of 2,268 divided by 3.6 multiplied by 9.81. So, we will have a value of 64 point. Your mass is equal to 2,268 joule divided by 3.6 meter multiplied by 9.81 meters per second squared. So, you will have a value equal to 64.22 kilogram. Next is a 800-gram ball is pulled up a slope as shown in the diagram. Calculate the energy it gains. So, I'll show you a diagram. The diagram, this 800 kilogram ball will be this one. So, as you can see, calculate the potential energy it gains from lower potential to higher potential. So, from the ground at a height of 0.20 meters. So, therefore, your PE is just equal to mgh. Therefore, we will have a value of mass, which is equal to 800 grams, which is 0.8 kilogram, multiplied by 9.81, multiplied by its height, 0.2 meters. So, therefore, we will have a value of 0.8 multiplied by 9.81 multiplied by 0.2, which has a value equal to 1.5696 joule.